Today we are going to see some of the sums related to the law of conservation of momentum. Here is a three sums or three examples are given to you. The another examples are the questions given accordingly you have to do by your own self. And also you have to do the exercise of this chapter after the end of this chapter. Right? So first of all we are going to see the examples related to the law of conservation of momentum. Generally, how do you know that this example is related to the law of conservation of momentum? Generally, in this type of question, there is a mass of two different objects are given to you, and the velocity of any one object is given to you. You have to find out the velocity of other one, right? So you can say that it is a sums related to the conservation of momentum. Right? Now, our example is example 9.6. Example 9.6. What is the question? The question is that a bullet of 20 gram is fired from the pistol of 2 kg mass with the velocity of 150 meter per second. What will be the recoil velocity of pistol? At here, in this type of example, first of all you have to decide which object is one and which one is second. So here it is a two object. The first one is bullet and the second one is pistol, right? So the object one. Taken as bullet and the object two. Right? Now for the bullet, you have to take a 1. So the mass of bullet is taken as m1, which is 20 gram. Then you have to convert it into kg. Then you get 20 divided by 1000. So it's a 0.02 kg. Now mass of pistol is 2 kg. Is 2 kg. Now, how can you find out? As you know that it is the sums related to the law of conservation of momentum, in which you have to just apply that the before collision or after collision, means before event or after event, right? The total momentum is same. So first of all, there is a thing what happening in this example. So the thing is that the bullet is fired from the pistol. Right? So the firing is the event, and before the firing all the things should be taken as initial, and after firing all the things should be taken as final. So before firing the velocity of a bullet and a pistol is 0, because before firing both are in stationary position. So according to it you can say that the u1 is 0 and u2 is also 0. But after firing, the bullet moves with the 150 meter per second. While you have to find out the recoil velocity of pistol. Understand? First of all, the masses are given to you, and before firing, the velocity is 0 because both are stationary. And when you fire, the velocity of bullet is 150 meter per second, while the velocity of pistol you have to find out the recoil velocity. So how can you find out? So first of all you have to use the conservation of momentum. The momentum is conserved, and just because of that, according to law of conservation of momentum, law of conservation of momentum. Initial momentum is equal to final momentum. The initial momentum is m1 u1 plus m2 u2. Final is m1 v1 plus m2 v2. As you know, right? We have taken the ma ua mb ub is equal to ma va mb vb. And here Instead of A and B, there is a 1 2. So M1U1 plus M2U2 is equal to M1V1 plus M2V2. Put the value. M1 is 0.02, U1 is 0, M2 is 2, U2 is 0. M1 is 0.02, V1 is 150 plus 2, V2 you have to find. So this becomes 0 plus 0 is equal to 2 by 100 into 150 plus 2V2. This 0 I cancel out. 5 is a 10 and 5 is a 50. So 0 plus 0 is 0 is equal to 3 plus 2V2. Take this 2V2 to another side, it becomes minus. So it is minus 2V2 is equal to 3. Right? So what you get? A minus 2V2 is equal to 3. Take this 2 on the other side, then you can find out V2 is 3 by minus 2. So V2 is 1.5. So it's a minus 1.5 meter per second. Generally minus is just because it just moved in the opposite side of the bullet. When you fire a bullet, fire just goes in forward direction while the pistol is just goes in a backward direction. Both directions are different just because of that. This one is a minus. So the recoil velocity of pistol is 1.5 meter per second. The recoil velocity is 1.5 meter per second. So like that you can easily find out the velocity of the other object with the help of the first object when the momentum is same, in which you need two masses of an object and the initial and the final velocity of any object. Only the one thing should be unknown, then you can easily find out that thing, right? Just say it. Now, our next question is question 9.7, example 9.7, in which there is a one girl of 40 kg mass moving with 5 meter per second in a straight line, right? She just jumped on a wooden plank with wheels which has a mass about 3 kg, right? The wheels are frictionless, so boat moves. What is the velocity of girl? Right? There is no any other unbalanced force is applied on them. So first of all, example 9.7. So first of all, we have to just find there is a two objects. Which are the objects, right? So first of all, 9.7. Which are the objects are there? So there is a two objects. One is a girl and the second one is a wooden plank, right? So first of all, object one is girl and the object is wooden plank. So I'm just write a wood, right? Okay. So first of all, she jumps on that plank. That's the main thing, is a concept, right? So before jumping and after jumping, you have to take the initial and the final. So first of all, we have to just write the masses of both of them. So mass of a girl is 40 kg, while the mass of wooden plank is 3 kg. So before jumping, the velocity is u1 and u2. At here, the girl's velocity is 5 meter per second. Before jumping, she just run with the 5 meter per second and then she jumps on wooden plank. So when C moves with a 5 meter per second, that wooden plank is a stationary. So U2 is 0 meter per second. Right? So when C jumps on it, what will be the velocity of girl? Means you have to find out V1. But for that you need a V2. But as you know that the girl is jumping on that wooden plank. It's a one type of skateboard. Right? You can see the figure in which that girl is moving on a skateboard. So the velocity of that girl and skateboard should be same. Then they can go. Right? So when she jumps, she goes with the same speed of that skateboard. So V1 and V2 both are same. If we take it as a V, then we have to find out that V. Understand? So velocity of girl. If you want to find out the velocity of girl, then the same velocity is of that wooden plank. So all the things are given to you. Now you have to apply the conservation of momentum. So according to law of conservation of momentum, according to law of conservation of momentum, initial momentum is equal to final momentum. The initial is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Put the value. M1 is 40, u1 is 5, m2 is 3, u2 is 0. M1 is 40 and v1 as a v, right? M2 is 3, v2 is v, because both the velocity are same. Now 40 into 5, it's a 200 plus 3 into 0, 0. 40v plus 3, right? So 200 plus 0 is equal to 200. 40 plus 3 is equal to 43v. So 43v is equal to 200. So v is equal to 200 divided by 40. What is the answer? So 4.65 meter per second. You have to just do the division, then you get the answer 4.65 meter per second. Okay? If you want, we will look at here 200 divided by 43. 43 4s 4 3s are 12. 1 16 and 17, 172, right? So it's 8 2 280 6 6 3 18 1 6 4 125. So it's 2. Here it is 2. So it's a 5, 50, so it's a 0. So you can say that the answer is 4.65 meter per second. So like that you can easily find out the velocity of gun and the wooden plank, because both moving in the same direction. So the answer is plus. The girl is moving in the direction of a wooden plank and then she jumps. So the velocity of that, or motion of direction of the motion is same. So you get the answer which is plus, right? Just save it. Now, example 9.8. opposite teams are just going towards the one ball to hit it, right? During that time, they collide with each other. If the mass of a first player is 60 kg and he is moving with the 5 meter per second, while the second player has a 55 kg and moving with the 6 meter per second, then after collision, in which direction, with what velocity they fell, right? At here, you have to neglect the friction of earth. So there is a two player of opposite team are moving for the one ball. Both are in opposite direction to each other. According to figure, you can say that the two players are moving in the opposite direction to each other as they are from the opposite team, right? So if one of them taken as a positive, then the second one should be taken as negative, right? And when they collide, because of some of the momentum, they fell in a one direction. It can be of a player 1 or it can be of a player 2, right? You have to find out then in which direction they move. They are moving towards the first player or towards the second player. And also you have to find what is the velocity for falling down. So at here there is a two object, player 1 and player 2. So object 1 is player 1 and the object 2 is player 2. Mass are given to you. First of all, the mass of player 1 is, what is the mass? Is 60 kg. While the mass of second player is 55 kg. Before collision, they are moving with some speed. So U1 and U2 is given to you. U1 is 5 meter per second, while the U2 is 6 meter per second. And when they collide, they fell at some place. So V1 and V2 both are same, that you have to find. Because when they collide, the speed becomes same and they fell down at some point. Okay. The main thing is that you have to take this velocity as one of them as a positive, the second one should be taken as a negative. Because both are moving in opposite direction. So if I take 5 as a positive, then you have to take 6 as a negative. If you take 6 as a positive, then you have to take the 5 as a negative. Right? The main thing is that whenever you get the answer of V, if the answer is minus, then you can say that both player will fall on the player 1, in the direction of player 1, because they are moving in the same direction of this player 2. So whenever these two are striking, they fell at some point. If it is taken as negative, then they fell in the direction of player 2. And if then it is direction of player 1. Right? So at here, first of all, we have to apply a law of conservation of momentum. Law of conservation of momentum. So according to it, initial momentum is equal to final momentum. Initial is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Put the value. M1 is 60, u1 is 5 plus m2 is 55, u2 is minus 6. m1 is 60, v1 is v, and m2 is 55, v2 is also v. Right? So add here 6 5 is 30, so 300 plus minus minus 6 5 is 33, 6 5 is 33. It's a 330 is equal to 60v plus 55. So you get minus 30 is equal to 115v. So the v is equal to minus 30 by 115. So what is the answer? answer is v is equal to minus 0.26 meter per second. You have to do the division. So according to it, you can see the answer, which is minus. So both player will move with a 0.26 meter per second, but they are moving in the direction of player 2. Both, when the boat just collide with each other, due to the higher momentum of player 2, they fell down towards the player 1, right? Towards the player 1. So it is in the direction of player 2. So here it is the answer. Just see it. So this is the examples related to the law of conservation of momentum. Here some questions are given to you on the page number 126. There is a 4 questions, right? They are also related to the third law of motion and the law of conservation of momentum that you have to do by your own self. And also you have to do the exercise of these chapters, right? So our chapter number 9 is completed here. From the next lecture we will see the another chapter.